Welcome to Code Rage Mobile and this presentation adding iOS sensor support to your mobile apps. My name is Ohlsson and we're going to dig right in. Not too many slides in this presentation, and we're going to cover here the accelerometer, the gyroscope, location or GPS if you will, orientation sensor. We'll look at a generic sensor info example. And we'll throw in the share sheet because it's using the camera as well, which is pretty much a sensor. So the rest of this will be demos. So let's go ahead and dig right in. We'll go ahead and pick up the accelerometer example first. That is going to be in iOS code snippets. These are all there for you in the paid for product and also in the trial, and of course they are also available even if you don't have anything. You can go to our source code repository and take a look at these samples as well. So let's start with the accelerometer demo. So here we have an iPhone type layout. We have a switch that turns on or off the accelerometer. Then we can have acceleration X, Y, Z. We can have angular X, Y, Z. We can have motion and speed. We have a motion sensor component. And we have a timer. And the timer is simply going and looping through and turning on and off the available properties. Based on the available properties on the sensor, it will turn on and off the views in the list view. By turning them visible to true or false. And let's see, that is pretty much it. So it will loop through here, and let's see what the update frequency is on the timer. It's running at 50 milliseconds, so 20 hertz. All right, so let's go ahead and see what this looks like. I have my iPad through reflection over here. So I'll just go ahead and deploy and run this application. It's going to compile, link, and deploy, and kick it off all through the PA server, the platform assistant, as usual. So anytime the accelerometer should pop up. Right, there it goes. And the first thing I see is my switch for turning it on or off. I'm going to turn it on my iPad. And I see that I get acceleration X, Y, and Z. They're fairly constant. It is a little shaky in the room here, mainly because of the AC and maybe some fans, and maybe my table isn't as stable as I thought it was. So if I tilt this now, I'm tilting it forward. You see the Y value is increasing. Oh, there goes the orientation as well. Flip it back just for a second. I'll set it back to somewhere around 0, and I can flip it towards me. I get to negative Y values. If I put it again horizontal or flat on the table, I can then turn it the other way, sideways, and I get the acceleration values for X changing here. You see that it's flipping back and forth as well. And then finally the Z value, if I go up, you see it goes in one direction, and if I go down, you'll see it goes in a different direction. So it can actually detect whether it's being dropped, thrown up in the air, or of course, moving around in space. Alright, so that's the accelerometer demo. Very, very simple demo, really. Let's see here again. There's really only 3 or so methods implemented here. Mainly the one for the timer, for displaying the different property values. Okay, so let's go over to the gyroscope. Slightly different demo. The gyroscope demo is also in here. Here we are going to go ahead and on a timer we're going to change the rotation angle XYZ of this three-dimensional rectangle. And the way we do it is we grab the T-Custom orientation sensor, the first instance. So if we have a T-Custom orientation sensor, we'll get the X, Y, and Z values from that, and we'll assign those values directly to the rotation angle of the X, Y, and Z on the rectangle, on my 3D rectangle. And let's go ahead and run that, see what it looks like. It's going to compile, link, and deploy. And we'll switch over to the iPad. It's going to launch the application momentarily. There it goes. There's my cube. Now I can start tilting this. If I tilt it forward and sideways, and I can jiggle this thing around. And you can see that we can make some sort of representation of how we're tilting the device in space. All right, very simple demonstration there. Next, we will go ahead and open up the location demo. A location demo looks like this. So here we have a couple of things. We have, first of all, a location sensor. It has an event, location sensor on location changed. If we get a location change, we get a new location, and that has a latitude and a longitude. We can simply put those into the text properties of these labels, latitude and longitude, that are on the design surface here, latitude and longitude. So we'll put that information right here. These are actually list box items, sorry, not labels. Okay, so and then we also have a URL here, maps.google.com, and there are two parameters, %s, %s. These are for the longitude and latitude, so that we can display our location on a map. The way we do that is we have a TWebBrowser component, right here, and when that event fires and we get the locations, we simply go ahead and format the Google Map URL and stuff in the latitude and the longitude as string values, and format it properly as a URL, and then we tell the TWebBrowser component to navigate there. We have a few more things here. We have a trigger distance and an accuracy. We can either set it numerically in this number box, or we can use these buttons, up and down buttons, to increase and decrease the values. And of course we have the activation for the sensor on or off here as well. So if we go ahead and run this on my device, again we'll compile, link, deploy, and through the PA server it will launch the application onto my iPad, and it will shut down the previous demo that I had there hooked into the debugger real soon now. There we go, shut down, and then it brings up the location demo. Okay, so when I now turn on the location sensor on my iPad, it will start getting location information. I'm somewhere at latitude 37 degrees and longitude negative 122 degrees. And it tells me here that, let's see if I drill in a little bit more. We see that I am very close to, if I tap on these things here, oh, it doesn't display it. This is in Scotts Valley, on Scotts Valley Drive, and we are actually, in real life, we are right about here. Okay, let's go ahead and run this on the simulator, and we'll see something interesting there. So again, it's going to compile a link for the simulator, which is a i386 executable as opposed to an ARM7 executable. PA server is going to go ahead and launch the simulator and also launch the application in the simulator once that pops up. And in the simulator, we can actually simulate location. Could be interesting to see where I was last. It may still be set to Guadalajara, Mexico, or something like that. So let's go ahead and see what it says here. We will turn on the location sensor. Okay, no, I had set it back to Scotts Valley. It looks like. Actually, no. This is simulating a freeway drive. That's right. So what I can do is actually I can go up here and change the location to custom location, and this may be the Guadalajara. Let's see. Yep, that is Guadalajara. Zoom out here. So that's where I last launched XE4. So that's Guadalajara. And as you saw here under debug, we can actually, for the iOS simulator, go for a bicycle ride, and go for a run, or a freeway drive. So freeway drive was somewhere on 280, close to San Jose, Cupertino. City run, I have no idea where it is, but it looks like it's close to that as well. We can stop the updates here because they come in way too frequently. We see here that that is close to Santa Clara, San Jose, Palo Alto as well, south of San Francisco. So pretty useful for being able to test location updates. Of course, when you do it on your device, you can take it in your car, make sure the passenger is doing the data entry or checking it when you're driving on the freeway, or driving at all, I guess. Okay, so let's go to the orientation sensor demo. Make sure we don't save that. The orientation sensor demo is also in here. Orientation sensor. Go ahead and check it out. So here we have, we can display tilt or heading, which is compass heading. We get tilt or heading displayed in here. We have an orientation sensor component. It has a couple of events on data change and on sensor choosing. So here we do a couple of things. We drop the data into the list box labels, and on the choosing we figure out whether we are using the heading or we are using the tilt values. Okay, so let's go ahead and run this on my iPad. Compiling, linking, deploying. Just going to shut down my previous application on my iPad. Right there. I'll launch the new one. There it goes. Okay, so now I have it set for tilt. I can set on. You see that I get the tilt values like I did before. This time they're in degrees. So as I'm tilting at 45 degrees, I get roughly 45 over there. And if I go over to turn it off and I set it to heading instead, It doesn't work. Oh, it does. A little slower to update. Okay, there we go. So here I'm getting the raw XYZ values for my compass heading, how I'm oriented in the Earth's magnetic field, essentially. Okay, I can turn it off. It stops updating, and go back to my IDE. Then the next thing we were going to do was go ahead and take a look at sensor info. That is in a different directory. It's in samples, FireMonkey Mobile, sensor info. Looks kind of strange on the form here. Everything's going to be set up in the onCreate event. We're going to realign the list boxes and stuff like that. And we're going to pull all the different sensors that are available at runtime on this particular device. Let's go ahead and try it on the simulator and see what it does. I'm going to flip over here to my simulator, and just like on my iPad, it's going to shut down the previously running application, and it's going to launch my new one. So that should be popping up real soon now. Sometimes you wonder if it actually did something. Oh, interesting. Okay, that usually goes away if we do something like click on here and say clean and rerun. This time I'll just sit here until it actually does something. Okay, deploying. And launching. Okay, so here we see that we have some location sensor. We have nothing environmental, no motion, no orientation, no mechanical, no electrical, no biometric, no light, no scanner. What's under here? Okay, oh, it wants to know my location. Okay, cool, that's fine. Okay, so here we get the raw data. Interesting that I have some speed. Oh, yeah, that's right. Let's see. What am I doing? I'm on a city run. You can see that I'm going 3.3, and I believe this is miles per hour. That would be a walking speed. Not sure. Could be some other unit, meters per second maybe. Okay, so let's go on a bike ride. Starting out, accelerating. All right, that's a slow bike ride. Speeding up. Okay, there we go. Come on, 7 miles an hour, 8 miles an hour. All right, now let's go for a freeway drive. Starting out, accelerating. Accelerating very slowly. All right, 25 miles an hour. All right, so let's return here. Oh, I thought I clicked it. Okay, there we go. So now back to actually running this on the device. We're going to get more sensors on the device. Compile, link, deploy. Go over to my device. Hide the simulator, and it's going to terminate the existing application and launch my new one. So now I'm on the physical device. So now I've got more stuff here. I have a, you can see I have an accelerometer. Okay, I can get all those values like you saw before. Much faster update speed at this point. We can go back. We can look at motion detector. So here we have acceleration X, Y, and Z, and also angular acceleration. So the faster I turn this thing around, the higher values I'll get. Inclinometer. I can see my tilt values in degrees. Oh, I flipped it over again. There we go. Almost all the way down to 90 degrees. Somewhere around there. Flip it back over. So here I can build my my level if I wanted to, right? Compass 3D, just like we saw before. How I'm oriented in the Earth's magnetic field. Right? Hit return. And I can see that I don't have any mechanical, electrical, biometric, light, or scanner sensors here either. I have the location though, like we had before. Tells me the magnetic heading. Go all the way around somewhere. There we go. True heading, magnetic heading. Speed is actually standing still. So -1 for some reason is standing still instead of 0. And I have the latitude, longitude, and I also have the altitude, which is cool. So I can get to all of that information if I want to through the iOS location sensor. Pretty cool stuff. You can take a look at that demo and see how it works. All right. Last thing I want to show you is the share sheet demo. And let's close these. Right here, the share sheet demo is available on this page on the start screen. I can open it right here. And one of the things that I usually do is I modify the style here, just to show you how to do that. So the style of this speed button should, in my mind, be a camera icon, which is somewhere up here. Oh, did I miss it? I missed it. I skipped too fast. Here's my camera button. And my share icon should be this guy. Okay. I'll go ahead and slide it over here, anchor it to the right side. And let's go ahead and run this on the simulator first. And we'll see something interesting. Going to shut it down, and you saw that the camera icon disappeared. That's because the simulator doesn't actually support the camera, and it doesn't actually support the share sheet very well either. If I click on here, I'll just get really strange artifacts over here happening. So what I'm going to do is real quick switch back to the device and show you what it actually is supposed to be doing. So again, we compile a link and we get our ARM7 app over onto our iPad, and we hide the simulator. It's going to shut down the existing application and launch our share sheet demo. So now what we can do is we see that we have a camera icon. I'm going to go ahead and click on the camera button. It opens the shutter. I can see my very interesting wall over here. If I flip it around, I can see myself, and there I am. So if I look in the camera and I take a picture, there we go. I can go ahead and, okay, let's say we like that picture. And say use, and why not put this on Twitter, just for fun. And we'll say, recording code Rage sessions, and a couple of exclamation marks. And why don't we put some tags in? Why not like code rage? Oh, and Delphi and XE4, like that. Send it. There we go. Go ahead and go back to the IDE, see what it's actually, what it did. Let's go to a browser, see if it did it. Go to Twitter, and see if it put my image there. Oh, there we go. It put my my image right there. All right, not my best picture ever, but it gets the point across. So what are we doing here exactly? Like I said, camera is a sensor, obviously, so that's why this fits in here. So on the camera icon here, we have a action. Take photo from camera action. My action list is up here. Here's my take photo from camera action. What it does, oh, sorry. On the action, I have an event, a very important event called onDidFinish ticking. And it will take the image from the camera and assign it to the bitmap on the form. Image camera picture is this picture right here, image camera picture that is aligned to the client on the form. Finally, the other one is show share sheet action. This action has an event. In this case, it's called before execute, and it will take the bitmap that is on my screen and assign it to the bitmap property of the show share sheet action, and that is what will be shared. The rest is taken care of by the operating system, iOS in this case. And the share sheet is being displayed. You can pick Facebook, email, message, Twitter, etc., etc. And that is all for these demos. So we covered the accelerometer, we covered gyroscope, location, orientation sensor, custom sensor info, where you can get all the information of all the sensors individually, and finally the share sheet example. With that, I'd like to thank you for watching this presentation, whether you did so live or whether you did so as a replay. And now we will go to questions.
So here's the first question. I don't know if you can hear me because I'm away from my phone.
I can hear you okay.
Okay. Could the accelerometer be used like those accelerometers you wear when running in order to stipulate energy expenditure? And go ahead, Anders. And then I have an app I'm supposed to be finishing about, which is a pedometer sample.
There you go. Sure. Yeah. So you can detect movement with the accelerometer. You would of course have to filter the data yourself. There's no built-in support for it, as far as I know.
Yeah, most of the pedometer apps that I've seen do calculations based on things like time, distance, and also the hardness of the acceleration to see if you're walking versus running and so on. The algorithms I've seen for whether you're walking or running are usually based on taking an average of the accelerometer hits over a period of time, over a second or a couple of seconds, taking 5 or 10 samples, so you can actually track to see when a movement actually happens, an acceleration happens in some direction, versus just saying every time there's a change, do something. So that way you can have a more sample of, again, is it a hard running, is it a faster cadence, things of that kind. And of course you have time. With location, you also have distance, right, that you can measure.
Right, and the location sensor will give you speed as well, so you can estimate whether somebody's driving a car or walking or running based on the speed, and then of course you can figure out do some signal analysis, like you said, on the changes of the acceleration.
Yeah. Okay, Robert has a two-part question, so I'm going to read part A. A number of existing aviation moving map apps use preloaded images that are displayed using a technique that makes the chart map look seamless as the aircraft moves. Sort of like I think Google uses a tiling system. Is there a sample that demonstrates how to implement kind of a moving map?
We don't have a sample like that as far as I know. We've got the examples, like the, what was it called, the fire photo? Or
well, there's fire
app we had.
Yeah. I don't know. Maybe there's a way to, in the TWebBrowser, it has a canvas. Maybe you could move the latitude and longitude around to capture bitmaps of parts of Google Maps, but maybe you're not supposed to save those tiles. I'm not sure.
Well, that would be using a web browser, so that would be probably not as efficient as displaying the images on the canvas and sliding them back and forth, if that's what you're looking for.
Yeah, I guess the other way is if you have a pre-stored map, either as an SVG or as a bitmap, you could figure out your coordinate system to do offsets to move along, right? In kind of a sliding window. But we don't have an app. Sounds like a great app demo to build for iOS, for Delphi iOS. And the second part B, is these same existing aviation moving map apps are able to have an icon representing an aircraft using internal or external GPS appear at the top of the chart. Is there an example that, that does something to implement this technique? I mean, you can put images on top of images. You can do layers in iOS apps, right? Or in FireMonkey apps in general.
Yeah, you can have an icon of anything that's a transparent PNG file, and you can overlay that on top of anything.
Yeah.
My analog clock example in the App Store, for instance, is when you turn on the FireMonkey logo, it's the second hand. That's a transparent PNG file that's sitting on top of everything else on the UI, and it's moving around.
And Frank posted a note saying, if you want to, you can go to the map kit that's part of iOS and do a bunch of stuff. And you've got a session coming up right after this is about creating iOS apps that need to call iOS APIs that we haven't wrapped yet, right?
Right. I'm not going into the map kit, but I believe somebody, if you Google it, you can probably find somebody that wrapped map kit, at least a beginning wrapper for it.
Yep. And, and Frank is saying, yes, Lars did it. So just search Delphi iOS map kit. Probably find it. Let's see. Bruce is asking, is there a lot of overhead reading sensor details, or is it quite fast to get the sensor information?
It's quite fast. I mean, I haven't timed it myself, but you can definitely get lots of update very quickly and respond to them. So as far as I know, there's no overhead from our side.